Okay, so before even talking about this function or kind of this program, there's a few things that you need to know. And we'll begin with function definitions. And if you're new to programming, it's a bit difficult to think about how these functions work because they're completely unique and programs completely depend on the understanding of these functions. So we'll begin by kind of making an analogy with math. You know that you have, let's say, a function f of x is equal to, let's say, x, or we have g of x is equal to x cubed plus e to the x, or we can say we have a function h. We'll say t or a. H of a is equal to a to the 5 plus 5 over a squared. All of these are examples of functions in math. Now, functions in Python or in Java and any other language, they work the similar or literally the same way. They all follow the same structure. So here we can recognize that for each of these we have a symbol for each of them that identifies it. So we'll say f, g, and h are all, we'll say, names for these functions. Then we have three, or for each of them a variable. We'll say x and a are, we can call them inputs because that's what you put inside the function and then get something out of it. And the thing you get out is these things here. So we'll say dot 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 are output behaviors, we'll say. And now what that means is based off of what x or a or any sort of inputs are, they will manipulate it in a specific way. Here it's just, it gives back the input. Here it cubes it and then gives you the e to the power of that input. So they all behave in different ways, but in general, the behavior always gives you an output. So Python functions work the same way in that they are always a name or a symbol that you want to call, followed by, in brackets, the input. And then, this is where it gets different. You have colons instead of equal signs. And then you begin defining the behavior. And this will be in the function body. And this function body has a specific name, and it's called the function scope. And all that means is when you refer to any sort of behavior, it is unique to that one function. So here, the only differences you have is that instead of being a one-line definition where you can define the function and its behavior in one line, Python allows you to define it any way you like, and that's giving you a lot of freedom in how you output things as well. When you're creating a function in Python, the input, same in math, you can have f at x. We can also have, let's say, g at x, y. Mathematical functions can also be dependent on two different variables. So g at x could be, xy plus y cubed plus x to the y. You would require two variables for this to give you an output. Otherwise, you would have no idea how to actually solve the equation. So Python works the same way. Your input doesn't have to be just one number. It could be a list of numbers. It's easier to give everything a single letter symbol, but in math as well, you can give it a whole word as a symbol or a name. In Python, it's much easier to give things names because it's a typed out language. It's much easier to type out a whole name than to write it out every single time. So it gives you the freedom to give more descriptive names to your functions and your inputs. So we'll begin with the first example. Here, for the sake of understanding, these are all very random names. They have nothing to do with how the program works. It's just a matter of showing you that it's versatile. And also, if you depend on the naming of functions, you won't fully understand what they do. So having arbitrary names helps you to understand them. So here we have two functions. We have Dragonfly and Dragonfly2. Now these work the same way, but they have key differences in how they outline their behavior. So here we know that this is the name, we'll say n, and this is the inputs, we'll say I1 and I2. So here we see that Dragonfly is dependent on two variables, which we called pineapple and kiwi. This could have been any name, x and y. But for the sake of programming and understanding code, and so that if you become a developer, you give your variables descriptive names so people know what you're doing. In this case, not. So just for the sake of understanding. So here we say that we want to create a new variable. So a new kind of placeholder that will store the product of this. So here we want to take whatever number is stored in pineapple, multiply it, which is this part right here, by kiwi, and then divide it by 2. And as well in in Python, it follows PEDMAS rules. So whatever rules you learned about uh, evaluating mathematical statements, the same applies in Python and most other languages. So here we're saying that I want to store the product of this function or this statement. We'll say we can call them, x, y. So x times y divided by 2. I want to store it in this new variable. We can say z as well. And then I want this function to return z. The return statement functions as a kind of a carrier for information. So if you have some function, here we have the behavior. Everything in orange is the behavior of the function, so how it actually handles the inputs. This final statement, the return statement, is how it handles the data or the actual calculated value it got. So let's say you wanted to create a program that calculates how much money you want to spend. You could say savings, and then you want it to be dependent on, let's say, the amount of tax you pay and your income. This, based on some behavior, should return the amount of money you save, or should save in your savings. So you say return savings. So these work the same way. Return functions, or return statements, which is this part right here, are a carrier to send the data stored to another function. You'll see how that works later. And now Dragonfly 2 works the exact same way as Dragonfly 1. The difference is that we aren't storing the value of this evaluated statement in a variable and then returning that. All we are saying is that I want to return directly the product of this, or the evaluated statement of this, which is very similar to a function. So really, we could actually write this as a function. We'll say this is x, this is y. We'll call this, we'll say d. We'll say d at x, y is equal to xy over 2. Now, if you're not familiar with math, or it doesn't help you to think of it in a mathematical perspective, you can think of it as this. You have a certain, let's say, machine, and given two items, it will always give you a certain item back. So if you have, let's say, you have a dishwasher, and this dishwasher, you give it input, let's say plates, and what it gives back to you is the clean version of this plate. So return clean plates. So functions are just small actions that can be repeated just by calling it and giving it new values for its input. Now with Phoenix, it works the same way as Dragonfly, but it has a different type of behavior, as we can see here. Here we have just one input, watermelon, and all we do is we exponent. So this is the exponent function. So in the same way you have, let's say, some number a to the power of, let's say, b. In Python, if you want to do that, it'd be a double asterisk b. This is just a way of simplifying kind of the notation and how you write things. So here we put watermelon. You can say w, not for the sake of writing it, but in Python or written language, it's easier to write it out. To the power of 2 times, and this is just pi. It's not necessary to know what math.pi is right now, but for the sake of understanding, we can go back to the start of the function and see here where we say import math. Now the importance of this is, if you want to buy a car, you're not going to, let's say, build the car from scratch every single time. There are people that build these cars for you and do all the heavy loading for you. So in Python, let's say you want to do exponents like this here multiple times. You could do, let's say, you want to calculate how long it takes to do something. You can create a timer in Python. You don't want to do that manually. You don't want to define how time works and how elapsed time is just the difference in time. You can say that elapsed time is equal to the final time minus the initial time. These type of behaviors are already defined for you in things called packages. So math, there's also time. These are packages or programs and behaviors that other programmers have already made for you. So Python, there are hundreds and thousands of packages in Python, Java, whatever it may be. There are a few that are already built into Python, but there are more that you can find online and kind of import them yourself. So let's say, you have Python could be, let's say, the stock car, but if you want to, upgrade the lights or the steering wheel, you don't want to build that from scratch. there are companies that make these items for you. These companies that come with the packages, and what they supply for you are these individual components. So this package allows you to get the exact value for pi. Instead of you writing, can you store this variable called pi, make it equal to 3.1415, yada yada. You don't have to do that. Math.pi takes care of that for you. Now we'll move on to the next two. So koala to panda. Another important thing to know, this is not unique, but a special thing in Python. You can name your functions and variables in sort of specific ways, but in general, you can name them whatever you like. However, if you ever want to do a space, you must use an underscore to show that it's a space. The same way in written language or in English, a space shows you that it's a new word. In Python, these spaces say that this is a new part of the statement. Otherwise, if everything was together, it wouldn't be readable. Of course, it's not fully the case. Python can't understand things that are without spaces, but for the sake of understanding, you can say that these are needed so that it knows it's one single word. All right, and so with koala to panda, it's really the same concept as dragonfly. It's just his behavior is completely different. But in the end, we know that functions are always, again, the name. We'll say the input I, the behavior, and then of course the output. Right? So here we'll break it down. So we have here an input koala, and then we say I want to create a new variable called panda, and set it equal to koala double dash 60. And now what's double dash? Well, that's another function. So here, let's say you want to do 5 divided by 4. You know that's 1.25. But Python, on top of doing this regular division, lets you do 2 different types of division, or 3 types. This is the regular. There's also the double slash, which means floor division. So it would give you the smallest whole number of the division. So this would be just 1. So here it's saying that koala will be some number. I want you to find the smallest even divisor of koala, whatever number it may be. We don't know yet, so we want to make a kind of a universal function. Whatever it may be, do a whole number division by 60. Now as well, there's another one called modulus, which is here. The name itself is modulus. You can also call it mod. It's that's the only name it has. You won't find any other name for it. Modulus is just the difference in these two, or the remainder, if you will. So let's say you have 37 whole division 6. This would give you 6, right? Because it's the nearest whole number. But if you did 37 mod 6, you would get 1. Now, why is that? Well, in the background, we can write here 37 divided by 6 would give you 6, and then plus 1 over 6. Well, why is that? Well, we know that 37 is just 36 plus 1 over 6. So then from there we can get, but that's not the point. The point is that you know that 6 times 6 is 36, but then you have some small amount. This is the remainder. Now, this, the regular division would give you the exact value, but we would want to work with, whole numbers. So we do 37 whole number division 6. This would give you just 6, a whole number 6. But if you wanted to know, let's say, what's the remainder of this whole number division, you would get 1. And what it's doing in the background is it's 37 minus 37 whole number division 6. So it's checking, what's actually happening right now. So we'll say, sorry, it's not this. It's checking in the background, how many numbers go into 37, or how many times 6 goes into 37, and then what's left. Because division is just another type of multiplication. So we can say, 6, 12, 18, 24, 30, and then 36, and then we get to 42. So we can say that there is 6 sixes in 37 with 1 left, which we can say here. Now what's actually happening here in a kind of a mathematical way is that we get back 6 here, right? So this is just 37 minus 6 times 37 whole division 6. in a kind of more algebraic way, this is just a over b, or a mod b. Yeah, this should be modulus. A mod b is equal to a minus b times a whole division b. So it's always the remainder from doing that division. So from here, we find out I want panda to be the whole number of whatever number it is with 60, and I want koala. So the number we originally got, I want to reassign it to the remainder. So in math, usually you don't redefine numbers halfway in. You keep them the same so that it stores the same number, or keep them within the same bounds. In Python and in programming languages, you can change what value these variables hold because they're placeholders. They're easy ways to access a certain number. So koala, or any number, we can redefine at any point in the program. So here we're saying that koala, whatever it once was, I want you to take that number and do the remainder division by 60. And then from there, I want you to return this new panda variable I made and the value it holds. So koala whole division 60, and my new value for koala. Now here, koala to elephant giraffe does the same thing but in a longer way. So now we create two different types of variables, or two different variables, elephant and giraffe, and these have their own behavior. So it takes koala, we can also call this x, and there's a whole division with 3,600. Then we reassign koala to the remainder division. Then we make a new variable called giraffe, and it holds, again, koala with whole division 60. And then koala is then again redefined to remainder division 60. And then the function returns each of these variables. Now this is where kind of the changing of variables affects your code. So Python is read line by line. So top to bottom, the same way we read a language from left to right, Python reads from top to bottom, from left to right. So here, what's happening is we have a variable storing the whole number division with koala and 3,600, but then we rewrite the value of koala to be something else. So from now on, koala is a new value based on what it was here, based on kind of this part right here. So we can label these, and we'll say this is koala 1, or initially. This is also koala 1, but then we redefine koala 1 in terms of what it once was. And then from now on, we use this new value of koala. And then again, redefine koala here. So to the return statement, this koala here is the third new value for this function, for this variable. So in Python, when you update something, it goes from top to bottom. So since everything is interdependent, functions are dependent on variables. When you change one of the variables, you don't create a new one. You change the same value or the same symbol. You change its value, so what it corresponds to, and does it from top to bottom. So you can begin with one number here, but then redefine it, and then use that new number. But you need to make sure that you know that these three koalas don't hold the same number. They change every single time. And that should be good. From here, you should have learned about operators, which are just plus, minus, star, which is the exponent. 1 star is just multiplication, and then of course whole division, regular division, and mod division. So the same way that math has operators, so does Python. And the return statements act as carriers, so they give you the actual value of what you want to do. So the return function can give you back, let's say, the plates that you cleaned from the dishwasher, or it can give you back, how much you need to save. Import is a keyword. When you want to use someone else's program that's already made. So math is an already made program, and you can use what they've written for your own programs. And import allows you to do that. Everything in purple here, the more you code, the different kind of websites or applications you use, one thing you'll see is that certain letters are always colored in a certain way. So import, def, return. Now the same way that you have some names already made for things, like say, if I were to call the earth something else, we'll say pineapple, people would get confused because there are already predetermined names for certain things. In Python, there are certain words that are already made to have a function, to have meaning. So you can't call your variables these specific things. And And these words are called keywords. So these keywords cannot be redefined. They can't be set to new values. They can't be their own functions. They are all set in stone, and it's the only way that Python knows how to actually read your code and do what you want it to do. Yep.